Okay. Oh, that's the wrong one. Alright, so we're looking at math induction. And remember we had our 3-part outline. Okay? We had our 3-step outline. Thanks. Bye. Where you plug it in, you plug in 1 and see if it works. Then you plug in K and you just say it works. Okay? That's all there is on step 2. Then the real work starts on step 3. Okay, with the K plus 1. Alright? So let's step through this example here. Let's first of all understand what exactly we're proving. Can someone explain what this sum is saying?
It's the sum of n times like every so everything is every number
identity.
up,
Hang on, let him talk.
every number up to n. The sum
Yeah.
of all of that. So
It's the sum of the integers from 1 to n. Okay, good. So we're just adding 1 plus 2 plus 3 plus 4 all the way up to n. Okay. Now, if you think about that, that is an arithmetic sequence with a common difference of 1, right? And the first term would be 1, the last term would be n. So this really is just the formula for the sum of an arithmetic sequence when we're going from 1 to n, right? So, let me just encourage you too, this is not the time to drift, alright? This is a challenging concept, we need to make sure that we get it, alright? So you really need to focus here. The first thing that you need to do, when we're letting n equal 1, we're going to plug 1 in to the left side of the equation, alright? So what's the sum from I equals 1 to 1? It's just one term, it's just 1, alright? Well, now let's plug 1 into the other side of the equation. 1 times 1 plus 1 over 2. That's 1 times 2 over 2, which of course is 1.
Do we even do the first, do we even do the left half of the equation as well?
Yeah, we did the left half, we did the right half, okay?
What's the left half?
The left half is the sum from I equals n, or I equals 1 to n of I. Okay. And a lot of times that left half is just kind of really obvious, alright? But it's important to the whole proof that we actually state, yes, that equals 1, and that equals 1, therefore we know it works for n equals 1. Okay?
okay, so should we always pick n equals 1? As
Yes.
Okay.
Yeah. I mean, theoretically you could do it for any of them, but
Makes it easy.
alright, so now our second part is just a statement. Do not think too hard for part 2. Basically, copy that and replace the n's with k's. That's all you're doing for step 2. So, the sum from I equals 1 to k of I equals k times k plus 1 over 2. Okay? Now, one thing that may be helpful when you're doing this would be to expand it out. Alright? Now, we're definitely going to expand it out on part 3, but here it might be helpful. What we're doing is we're just adding 1 plus 2 plus 3 all the way up to k. And that'll be helpful as we get to our next step, especially. So now what we have to do is say, alright, if it works for up to k, will it work for the next value? What's 1 after k? K plus 1. Alright, so that's what we're going to try it. The sum from I equals 1 to k plus 1 of I. And this one we definitely want to expand out, because we're not really going to do anything with this, with the sigma notation. We're going to look at the expanded form. And that's going to be the key to our proof. So it's going to be 1 plus 2 plus 3 all the way up to k, and then the last term k plus 1. And I'm going to just put that in parentheses. It doesn't do anything mathematical. It's just so I can see that that's my last term, the k plus 1. Alright? Is everyone with me on that?
Yeah.
Okay. Now, here's the question. Does that equal this with a k plus 1 instead of k? Alright, so look at what it's going to look like. I put a k plus 1 instead of the k. And then if I put a k plus 1 instead of that k, what is this parentheses? It's a k plus 2. And that's over 2.
You need to
Oh,
simplify that.
Here it's k plus 1, and this becomes k plus 1 plus 1. So that's why we've got the k plus 2. Alright? No, and in this case, what we're going to do, this is going to be a proof, so we're not going to mess at all with the right-hand side. Okay? What we're going to do is we're going to deal with the left-hand side only, and make it look like the right-hand side. Okay? So, you'll notice here, well, what do you notice? As you look at all of this, what do you see?
There's no k plus 2.
You're right, there's no k plus 2, we're only going up to k plus 1.
We don't know what k is, so we can't say when the sum ends.
Okay?
Or this is sort of question, not really. How do we know that k is bigger than 1, 2, or 3?
We don't, but I mean, the idea is we could stop whenever we want.
Every number has a number like bigger, so every number has a k plus 1 basically.
Okay. And that's kind of the idea of the induction. Whatever number we have, if we know 1 works, then if we could show this works, then we'll know 2 works. And then if 2 works, we know 3 works. And if 3 works, then we know 4 works. That's why we're doing the k and the k plus 1. Alright? But maybe I'm not asking this question really well, I think. What is this?
A series.
Yes.
An arithmetic series.
We've seen this before.
The
Recursive.
sum
Oh,
of-
Recursive.
No.
Let's throw out words now.
Isn't where it's like S, then.
No, you guys are thinking way too hard.
Math.
No, you're thinking way too hard.
Addition, sum, so
We've seen that before, not a long time ago,
Addition.
like 2 minutes ago.
Plus 1.
And the question
it's-
above?
Oh, fourth grade.
Oh,
Yes,
right.
it's this, right?
Oh.
It's that. So what does that equal?
It's that plus k plus
k
1.
plus 1 divided
K times k plus 1 over 2.
Oh,
man.
my god.
That's just too
Also, k times
Wait,
k
what?
over
Christ,
2
Mr. Hicks.
plus
Did
k
you
plus
say
1.
that?
Alright, because you guys need to think. Alright, what?
So then you're gonna add the k plus 1 to that, and then equal the k plus 1 times k plus 2 over 2.
of course.
Yes.
Yeah, of course.
Alright, so it's plus that. Here's the first k terms. Now we're just adding this one extra term to it, right? Okay?
Oh, why is it over?
So, well, I wrote it kind of in anticipation. What we're going to do here is get a common denominator,
Oh,
okay?
so it just seems.
So I multiply by 2 over 2. And because this is all one fraction, right? So if we have 2 separate things, I need to get those into one fraction if I'm ever going to make it match this.
Yeah, we have to.
Alright, so
So it just seems.
we do this, and notice what I've got. I've got a k times k plus 1 plus 2 times k plus 1 over 2.
2 plus k. 2 plus
Yeah.
10 plus k.
You can pull the k plus 1s out, just like when we factored by grouping. Remember that? here's a common factor of k plus 1. I'm going to pull that out, and then what's left is the k and the plus 2.
Let's see.
And that's over 2, and that matches
It's easier than
that.
I'm really confused.
Okay?
Wait, what, it matches what?
You have to prove that.
How?
What we were trying to prove, we're there.
So pretty much, so you solve for, why would you solve for n equals 1 first? Like in step 1?
Why do we do that?
Yes.
Because here's the whole thought process. Okay? We showed that it works at least once.
Okay.
That's why we solve it for an n equals 1. Okay?
Let me see.
Then we're saying, suppose it actually works one time. This proves that if it works once, the next one will always work. Okay? So now when we put the whole idea together, since we know 1 works, we automatically know 2 works. And since we know 2 works, then we know 3 works. And since we know 3 works, then we know 4 works. And so on. Does that make sense? Okay. Out.
First of all, can you scroll down?
Mhm.
Alright, where does the 2k plus 1 come from? Over to.
You had this term right here,
Yeah.
and I just got a common denominator.
Oh, okay.
Oh, so you just,
I didn't write down the step twice, but maybe I should have. Yes, Ellie?
On the last one, I didn't get how you get the k plus 1. It is supposed to be 2 k plus 1.
Well,
Yeah, maybe you can find out.
if you remember when we factored by grouping, this is a common factor. Alright? It's just like if we were factoring, you know, kx plus 2x. If I asked you to factor that, you would factor the x out, and you'd have a k plus 2, right? So I just took out that common factor
The area under the ground.
and put it there. Okay?
Okay.
So when you take out a common factor, it's just itself. It's not 2 or it's not squared or anything like that. Derek?
Why did you multiply the k plus 1 times 2 by 2? Is that like very common denominator?
Yeah.
It's much easier than it looks.
I have another way to think about how to understand the last term.
Okay.
It's like the first term is 1 and the last term is k plus 1, so they add together is k plus 2, which is the k plus 2 there,
Mm-hmm.
and the k plus 1 divided by 2 is the total term, and divided by 2.
Let's avoid confusion.
No, that's excellent logic right there. Okay. What she's using, think about this, guys. What she's using is our. My eraser is so small. There we go. She's thinking of this in terms of the sum of an arithmetic sequence. The first term is 1. The last term is k plus 1, right? How many terms are there? K plus 1, right?
Oh yeah.
Oh, yeah.
N over 2 times a sub 1 plus a sub n. And then look at what that simplifies down to. That's the k plus 2. Okay? We'll put the k plus 1 here. And since it's multiplication and stuff here, we can write it.
Wait, how did you say that? That they're k plus 1 like total terms?
Yes, because we're going from 1 to k plus 1, right? So there's k plus 1 total terms. So, yeah, that's excellent logic. This is a little more algebraic. This one's a little bit less so, but I'm not sure how to explain it.
visual.
But anyways, Yash.
Oh, okay. How do you, for the the thingy. How'd you get k plus 2 over 2? You can't do that, right?
What, here? Just because this is multiplication. It doesn't matter if you divide first then multiply, or if you multiply first then divide. So I just wrote it all.
Like
Oh.
K squared?
Okay.
Well, we just don't bother foiling it. Alright, so,
Oh,
there's my eraser. Alright.
Do we have, like, if on a test, do we have to do it the way you did it? Or like if it makes sense a different way to us?
As long as, here, this is a cool thing about proofs, guys. I'm sure there are even more ways to do it. We just looked at 2. But, a lot of times there is more than one way to think it through. Okay, so if you see another way, that's fine. Yes?
Yeah, it's gonna sound really dumb, but yeah.
I'm
Uh-huh.
used to it.
On the, you used to, like, you divide the, your final answer, like the k plus 1, k plus 2 over 2. The second to the last thing you do, that. When you divide that, how does that equal k plus 1 times k plus 2?
If you graph it, you group them.
Yeah, it's like when we factored by grouping, and you pull out the GCF of the 2 groups, and then you end up with that common factor.
You do another one by yourself.
Yes, we're gonna do another one. We're gonna do a few more.
I can't handle one.
Okay. Let me minimize this. Stop.
Will they all be the same format?
Yes, that's the nice thing about math induction is it gives you the same
There's nothing nice about that.
the same process every time. Now, we ought to have more success than we did third period, because I accidentally wrote down the wrong thing for this third period, so we actually disproved something by math induction.
Yay.
We showed that it was impossible.
Is this the right one?
This is the right one, so this one ought to work. But anyways, let me show you this real quick before we get into that. These are not things that you need to memorize, okay? Do not worry about this, okay? We're not necessarily even going to use these, but I show you these because
We're about to do the next one.
we are about to do the next one, okay? But also, these are all things that have been proven using math induction. Notice what we're adding: the sum of the first n integers, the sum of the first n squares, the first n cubes, the first n terms to the fourth power.
Okay, couldn't we make a proof that states that if you square the next number, if you square the number, if the number squared plus 1 works, then all of them will work? Like, you see it's like I, then I squared, then I cubed.
Oh, you're trying to prove all 4 of these? Like,
Like
Or
prove
all-
that it'll go on infinitely.
Oh, like-
that
well,
makes sense.
here's the thing.
Well,
These are pretty significantly different. Okay, so there's not like there's not really a pattern to how these are changing. So, that's not a bad thought. If you did, you could probably make a lot of money. If you thought of a way to do it.
How much?
But,
How much?
We'll see
Just
it.
for curiosity.
but anyways, we're gonna try this squared one. Yes.
There was a homework on that thing. Was
Mhm.
it for,
Let's do this one, and then we'll come back.
or we're supposed to do it?
I didn't like tell you guys to do it, partly because we didn't get too far into the lesson yesterday, but yeah, we're gonna have some time here in a little bit where I'm gonna have you guys working together on some of these. So if you have a question on one you already did, I'd be happy to look at it
We
with
got
you.
Julio. No.
All right, so let's look at this, okay? What are we doing first?
We're going to look back at the other sheet. that you
Wait, can we
showed us.
try doing it individually first?
No.
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 Let's do one more. Let's do one more as a group, and then we'll let you loose, okay?
We let n equal 1.
Let n equal 1, okay? So the left side, what are we doing? Okay, that'll be for the right side. We'll do 1 times 1 plus 1 times 2 times 1 plus 1 over 6. Okay? So that's 1 times 2 times 3 over 6, which equals 1. Right? And the left-hand side is just 1 squared equals 1. 1 squared. Okay? So now look, they're both equal to 1. They don't have to equal 1 as long as they're the same when you're doing these proofs. They're not always going to come out to 1 every time on this first step, but they just have to come out to something that's the same. Alright, so does everyone understand this part?
Yeah.
Alright, second part. We're going to let n equal. Alright, so all we have to do is copy this and replace all the n's with k's.
And you don't want us to simplify, right?
No. Now, one thing you may want to do at this point is to go ahead and expand out that sum a little. 1 squared plus 2 squared plus 3 squared all the way up to k squared. Alright? And then that's going to equal k times k plus 1 times 2k plus 1 all over 6. Yes, Ellie?
So, the second one we just had to put it in.
Yeah, you're just plugging in k and leaving it. All we're saying is that that is true. Okay? That's all we're saying is that this value is true. Alright? Now, what I do want you to try to do on your own at this point is the beginning, just get what you're trying to get to right. Alright? Plug in that k plus 1 on the right hand side and see if you can get that expressed correctly. Don't foil the right side, no.
So do we need your like square k for the?
Yeah.
You mean in here, put k squared?
Yep.
No, no.
Why not?
Well, because n wasn't squared up here.
Oh.
You're just putting in k plus 1 each side.
But I is
I is squared, that's why each of these are squared.
So,
Mr. Hicks,
oh,
Oof.
can you check?
oh.
That makes sense. That would count.
What'd you get for yours?
Oh, you know what?
This is what you want.
You can get through the
Oh.
Okay. So you're gonna have this plus k plus 1 squared should equal all of this.
Oh,
Wait, so like, for n equals k, like that, does that make sense? The third step?
Make sure those are squared
Okay.
on the left side.
Yeah.
The right side. Oh, okay. That would be like the next step of what you're gonna
Yeah,
do, yes. Yes, that looks, it's over 6, but yes.
Does that make sense?
Yes, okay. So then put a plus k plus 1 squared. Because that's what you're doing in this one. There you go. Now, this is what we're gonna look at right now. Okay, so third, we're gonna let n equal k plus 1, okay? So it's the sum from I equals 1 to k plus 1 of I squared. That's gonna be 1 squared plus 2 squared and so on up to k squared, and then the last term is going to be k plus 1 squared. This time you do have to have those parentheses, okay? Now the question is, will that equal this with a k plus 1 in it? Alright? Now this is what you've got to be really careful about, otherwise you're never, no matter what you do to the left side, you'll never get it to equal. Alright? So, instead of a k, we have a k plus 1. Instead of a k plus 1, yeah, it's k plus 1 plus 1, so it's k plus 2. And then 2 times the quantity k plus 1 plus 1. 2k plus 3. And then that whole thing is over 6. So now we're going to leave this alone and work with just the left-hand side until we get here. Okay?
Do we sub in the thing from the second one?
Yeah, you guys are getting the hang of this, okay? Now we're going to sub in what we just said this one was. K times k plus 1 times 2k plus 1 over 6. And then that's going to be plus k plus 1 squared. Okay? Yes.
And how you got 2k plus 3?
What we're doing, stop. Here, it's 2 times k plus 1 plus 1 for this, and that's how we get this. You have to distribute the 2, so that's where we get the 2k, and then a plus 2 and a plus 1. Okay? I know we are rushing through a little bit of the algebra, so if there's part that you're not sure how we got from one step to another, just ask. Alright, so now how do we simplify this? This is where you just got to be careful. Ooh, stop. You got to be careful with your algebra. Alright, I'm going to clone this. There we go. Alright, so now I'm going to multiply this one by a 6 over 6. Okay, to get a common denominator, because our final answer we want to be one big fraction over 6. So I've got that part. Now this part, again, we're going to use that factoring by grouping idea. We have this group and this group, so I'm going to actually take out a k plus 1 from both of them. So watch this carefully. I take out the k plus 1, and what's left over? I'm going to use brackets. I've got a k times a 2k plus 1, plus I still have a k plus 1 left over because that was squared, and I have a 6.
You take it, never mind, line.
Right. So at this point, we just need to combine all these like terms to simplify, and then refactor it. Alright, so we get a k plus 1. This is going to be a 2k squared. 2k squared. There's a k, and there's another 6k, so it's going to be plus 7k. And then we have a plus 6. All over 6.
And that's k plus 2.
Can you go up a little?
I'll go back in just a sec here. K plus 1, and then that will factor
K plus 2 and
oh,
2k plus
X. K plus 2 and 2k plus 3. The factoring should be easy at this point because you know where you're supposed to end up. Now,
No.
I wouldn't just assume. This is running slow, sorry. Okay, we know it's supposed to factor into this, so let's just double check to make sure it actually does.
Right there.
K times 3 is 3K, 2 times 2K is 4K, that gives me a 7K in the middle. K times 2K is 2K squared. 2 times the 3 gives me the plus 6. So I know this is factored correctly.
Or do you do that?
Now, how would you ask this question on the test?
I would say
Prove
that inductively.
And then we just have to show our work.
Yes.
That's all. Okay.
One of those takes like 10
Will you
minutes.
take the false ones to true ones?
We better
No,
not
I'm
get.
not going to give you a false one.
Okay, good.
Yeah, you guys will spend 2 hours on one problem and.
We better not get like.
These
one-
are
Now-
the whole quiz, right?
Now, here's the thing. Here's the thing, if you listen, one thing we ought to do, and I know we didn't do it in the previous example, because it does just kind of make sense, but in order to be a little bit more conclusive, rather than just, here's the proof, we should say at the end, therefore, the sum from I equals 1 to n of I squared does equal n plus 1 times n plus 2 times 2n plus 1 over 6. It is, but it is conclusive. We're saying, therefore, as a result, this is actually true. Okay.
I think Alex wants to do one on the board.
Alright.
Take it, please.
I wouldn't do that to you. Alright, so what we're going to do at this point, and if you're watching on the video, I'll post the notes online. You can see the results, but I'm not going to have a bunch of time of silence. So but we're gonna try some of these in some small groups. We're not going to start with this one because that one is a little bit more challenging. We'll start with one of the ones that was listed originally for yesterday. We'll start here in small groups and then we'll show the answers. So I'll give you guys about 5 minutes to get as far as you can into it. Okay?
I understand.
And then we'll give the results. All right.